Okay, so we're in 3.3 talking about a thing called functions. When we did our PSAT review, we bumped by accident into functions. But here's the idea of functions. A function is just like a formula or an equation or whatever you'd want to call it, where x's will try to be put in and out will come some y's. That happened to you yesterday. When you did a lot of the equations yesterday, if it said y equals 2x plus 3, graph that. Okay. What you did was you made a table, you picked out some x's, you put them in, and out popped the y's. Okay, so that's what a function's about. You pick x's. Because you're picking those are called an independent variable. You can basically do anything you want. But if you're smart, what numbers you wanted to do were probably 0, 1, 2, -1, something like that. Other than this one, no, that one would have been fine. There was one in the homework that had like half x. If you want to be smart about doing numbers that have half x's, I wouldn't do 1. I'd go even numbers. Take numbers you can do half of, 2, 4, 6, stuff like that. If they had a fifth x, you'd probably pick 0, 10, 5, stuff like that. But the x's are called the independent variable because you do what you want. The y's are called the dependent variable because you kind of depends, you get what you get. Like, depending on what first choice you made, that's what affects the second choice that comes out. So independent variables in, dependent variables out. What was the final homework question? The two final homework questions about the x stuff was called the domain. It's another word. That's what's going in. And out comes the range. So those words will be back again today, and they'll be back in future years of your math life. So to be classified as officially a function, it has to be a formula, an equation that follows a rule if it's going to earn that title. So here's what it has to do to earn the title, and the first homework questions will ask basically, do these equations, do these formulas, did they earn the title of function? So here's the rule. No two ordered pairs, these guys, are allowed to have the same x, but have different y's. So for example, if I said 1, 2 is in this and 1, 3 is in this, those have the same x, those have different y's, so we would say no, okay? But that's the rule. If things have the same x somehow, but give you different y's, we're going to say no-go on that, and we are not a function. So y equals x squared, x equals y squared. One of those is a winner. One of those is a loser. Can anybody figure out what's what? First one is the winner or the loser?
Winner.
That is a winner. Why is this one a loser? Can you give me some ordered pairs that show why this loses?
Because the y's are, I don't know. I just took a guess.
What'd you say?
1 and -1 would give them different y's with the same x.
Okay, so if we put in, where's your ones and your -1s going?
And the y's.
Okay, so if we do 1 for a y and square it, we get a 1. If you do -1 for a y and square it, you get a 1. So those have the same x's, they have different y's, so this is a no. This is a yes, and you probably found that a little confusing. You probably are thinking to yourself, I'd really rather not do that on the homework 6 times. So there's a tool that will make our life easier on this. But before I show you the easier tool, question about the idea.
Is it because, like, you can't have the y squared?
These are both ordered pairs that work in this equation. And this happens to have the same x while it had different y's. So it does not earn the title of function because it broke the rule. Question about the concept? Because I'm going to encourage you not so much to think about it, but to do this a whole other way. Okay, so here's the whole other way. There's a thing called the vertical line test that involves you needing to have a graph. Okay, y equals x squared. What kind of graph was that yesterday? What shape? It was a parabola, also called a U-shape. So y equals x squared was a U-shape. X equals y squared. What did that do when I switched x and y? Sideways. The U like took a nap. So here's how the vertical line test works. You draw vertical lines. What do I mean by vertical? Straight up and down. So I'm going to draw straight up and down lines. This straight up and down line is going to touch this twice. That means that there's a pair of numbers, pair of ordered pairs that exist where it's breaking the rule. Okay, 1, 1, and 1, -1 would be points like these in this vertical stack. It broke the rule. We can see that because a vertical line touched it twice. Over here, if I draw vertical lines, it's only ever going to touch one time, or maybe not at all. And either of those is okay. So if you draw vertical lines and you touch one time or never, we're good. If you touch doubles or more, it's no good. I've had some people sometimes ask me, can I draw the lines this way? And I try not to laugh at them. Okay, but why is that a laughable question? It's called the vertical line test. So you can't do the vertical line test by drawing diagonal or horizontal lines, and otherwise it would be called draw whatever line you want test. So if we draw vertical lines and get single or no touch, we're good. If you get a double touch, we're bad. So here I've got a good and a bad. This is good. This is bad. Because here if I draw a vertical line, I've got 1, 2, 3, 4 touches there. This, anywhere I draw a vertical line, gets one touch. So that's good. I go like this. You'd say no. Because there are places that a vertical line can do a double touch. What you can't do is go, oh, well, if I draw my vertical line just right here, I'll get a single touch, so it's okay. No. It has to work everywhere. So that would have a double touch. No good on that. I could stand here and draw some more stuff if that helps people. Anybody a question about the vertical line test? I think that's what the first 6 or 8 homework questions do. They've graphed you stuff already, and they just ask, is it a function? Did it earn the title? So you draw vertical lines. If you get a multiple touch, no. Something there. Okay, second homework question set is going to ask you questions about the domain. So back to my little diagram and the conversation from yesterday. Domains have to do with x's. The x's are trying to go in. So when they ask you, what's the domain of these things? They're asking you, what numbers could you put in and have everything be okay? Sometimes you try to put numbers in and things blow up. Okay, we don't want those. We want numbers that if we put them in, they'd be okay. Generally, these answers are going to be everything works except, and then you've got a little bit of problems here or there. So it's often easier to think of who doesn't work than who does. So if you think about x's going in, most numbers you could put in for x just work fine, like 8. You can do 8 minus 3. You can do 8 plus 2. You can divide those numbers. 8 is fine. 9 is fine. 137 is fine. We don't want to sit here all day and list every number that's fine, because there's a whole lot of numbers. You could subtract 3, you could add 2, and you could divide the results. That's normally going to be fine. So can anybody think of anything on this that it's not fine? No, 4 would be fine. I can do 4 minus 3 and 4 plus 2 and divide the result. -2 is not fine. Why is -2 not fine? It makes 0 on the bottom. You're never allowed to have 0 on the bottom. So when they ask you the domains of fractional things, basically what you're asking yourself is there any way that this could get 0 on the bottom? And if there could be, you say x is not allowed to equal that number, which would be -2. Is there any other number that could blow that up? Nope. Let me change this one. If I go x squared plus 2, is there any way now that that bottom could be 0? No. So who works?
Everything.
Literally everything. So what's our symbol for that?
Boom, boom.
All real numbers. Everything would work just fine. If I wanted to take this one on, Well, what I have to do to this one?
Factor.
I'd have to factor the bottom. And that's a little bit of a mean question because we haven't really covered factoring in detail this year. It's popped up once in a while, a little bit. But here we'd have to factor the bottom. X squared goes X. With plus, the signs
Minus 6 plus 1.
are the same as those. When the signs are the same, we do what to make middle number? Add. So who multiplies to 6 adds to 5?
3 and 2.
3 and 2. So who should X not be allowed to be? 3 or 2. Anything else would be fine. Question about that?
Oh, so we're only doing it for the bottom and not the top?
Yeah, we don't care about the top. The top can do whatever it wants. The only rule for fractions is bottom can't be 0. How about square roots? What kind of numbers can you do square roots of? And I don't mean evenly, like square root of 7, that's fine. It fills your whole screen if you did it on a machine, but
Like
there's nothing
pi?
wrong with square root of 7.
Not do square root of like pi.
We can do the square root of pi.
Oh.
It would be
0.
1 point something. Can you do the square root of 0?
No.
Okay. Square root of 0
No.
is 0. We can do that, that's okay.
2.
Square root of 2 is 1.414 or something.
Everything.
It's not everything.
Negative numbers.
Can you do square roots of negative numbers?
No.
No. Okay, let's quick square root reminder.
Oh yeah, it has
The
What?
square root of 9 is
3.
3. Why?
Because 3 times 3 is 9.
3 times 3 is 9. Square root of 0, we had a debate about. It is 0 because 0 times 0 is 0. If you try to do the square root of negative 9, that is impossible. Because some people might say, why isn't it negative 3?
Because negative 3 times negative 3 is no.
It is. Negative 3 times negative 3 is positive 9. You could argue up here that negative 3 should be an answer to that one, and it should have like a double answer. Later in the year, we'll get into this. If this symbol is used, you only do the positive version. If I, with words, said to you, what are all the square roots of 3, using words, not symbols, then you come back with both of those answers. But negatives, you can't square root negatives. So 0 is good, positives are good, negatives are bad. Can anybody write a thing like this that has an X in it that describes that 0 is good, positive is good, negative is bad? What's that look like?
less than 6.
Say what? Greater than or equal to 0, that would be the domain. X could be greater than 0 and be positive, X could equal 0, but this excludes the negatives. How about this? 4 times stuff squared plus 5 times stuff plus 6.
Do you have to factor this one down?
No, you wouldn't have to factor. What kinds of numbers could you put in? To do 4 times stuff squared and add 5 times that same thing and add 6. Anything. So we're back to one of those again. Everybody would work. And I misspoke a second ago. This is the third homework group, not the second homework group. I skipped the call on that one. It's Monday. Stupid Mondays.
I hate Mondays.
So does Garfield.
Where's the one?
Question about the domains? This we did during PSAT review a good bit. So if I or the book says to you, f of x equals 5 times x minus 1, and follows up with, tell me what f of 0 is, what do we expect you to do?
Plug 0.
Plug 0 in. This is just setting you up that says, in a minute I'm going to give you some stuff, and I want you to take 5 times the stuff I give you, minus 1, one at a time. So then I give you 0, then I give you 1, then I give you 3. You just have to follow the formula of 5 times what I give minus 1. So 5 times 0,
0.
minus 1.
And
5 times 1,
1.
minus 1.
It's 5. It's 4.
5 times 3, minus 1.
14.
It's 14. If I went weird and did f of, pick a letter, any letter,
17.
letter,
Oh, E.
p. So if I want f of p, what would you
Stop.
put? 5p minus 1. You just continue, whatever's in the parentheses just goes where x is. If you replace x with a number, do the math. If you replace x with a different letter, then just replace x with a different letter. Question about that? Another thing I should tell you that I think I told you during PSAT review, if I say f of x, or if I say y, it doesn't make one speck of difference. If I go back over here to these questions and I change my y's to f of x's, or if I change my f of x's to y's, it's all the same. It's just a punctuation symbol difference. Question about those?
We had Olympic.
Good. Okay. So the homework today is going to finish with some graphing. So yesterday when you had squares, what were all the shapes? Use. Today they're going to throw in some absolute values and they're going to go a different shape. And again, like I said a minute ago, if it says y equals, or if it says f of x equals, it doesn't matter. So if this bothers you, just copy y. But if this bothers you, you have to get over it because the PSAT loves this. College books, they may or may not love that. I don't know. I like the y myself, but if they want to go f of x instead of y, hey, people are writing books and creating tests other than me. That's up to them. But if we want to graph something, and it's a mystery to us at first, how did we graph the other day? How did you graph in Algebra 1? What do we do? Use that little chart called a table. So I'm going to go x, y. Since I've got an x, y table, that's one of the personal reasons why I'd rather see a y there. If it's y equals, which side do you do your picking for?
Left.
X. So 0, 1, and 2. And then try them out. What's the absolute value of 0?
0.
What's the absolute value of 1?
1.
What's the absolute value of 2?
2.
And then we'll see where we are. Origin. Where's this?
Over
Right.
1 up.
Over 1 up 1. Then
Right 2 up 2.
2 up 2. And it looks like it's a,
Line.
it is not. Okay, anytime you get plain old x, plain old y, that's going to be a line. Anytime they do something else, it's probably not going to be a line. So it looks like a line, that means we have some incomplete information. So how can we get a little more?
Negative
Gotta
1.
try some negatives. Negative 1's absolute value
1.
is 1. So where is that?
Over.
Left 1,
Left.
up 1.
It's gonna be like a dumb key.
And then let's try one more just to be sure.
Negative 2.
Negative 2 gets 2's. So left 2 up 2, and it is going to be a v. Anything absolute value is going to be a v. If I switched x and y, what do you think would happen?
It's going to be an upside down.
Nope.
Sideways.
It's going to take a nap sideways. What turned it upside down yesterday? Negatives. Negatives would turn it upside down. What if I put in there like a +2 or a -2 or something?
Just move it.
It's going to like move it some way or other. And as we gain experience through the chapter, you're going to get quicker and quicker at knowing just that it's where it's going to move. Okay, but if I change this to be +4,
Up 4.
when I build the table, just all of these numbers would have to
Add 4.
add 4. So I'd get 4, 5, 6, 5, 6, which would mean
Everything just goes up 4.
everything just goes up 4 squares to be something like that. The two sides should be the same. What was the S word for that?
Symmetrical.
Symmetric. So we have symmetry there. There should be a mirroring thing going on. Question about V shapes. Last thing we're doing, this is called the least common integer function. You've never seen this symbol before, you've never heard of that. What this does essentially is it rounds everything down. So I'm going to build a pretty expansive table on this. Since it's y equals, you can first try to put in 0, 1, and 2. If you round down to, let's see, rounding everything down to the greatest integer less or equal to the number that we start with. So if I give you 0 and say round that down to the greatest integer that's less or equal to it, you would return 0. If you try that with 1, you return 1. If I give you 2, you return 2. As long as I give you whole numbers, you would return
Itself.
itself. Like if I dropped in -1, you'd give back -1. I give you -2, you'd return -2. We could sit there all day and we would never get anything back other than what I gave you. But we'll start with that. 0, 0, 1, 1, 2, 2. What's the only way that this thing is going to do anything? Is fractions or decimals. So let's say 0.14. I'll go with a 1. That would round down to
0.
0. 0.2.
0.
Rounds down to 0. 0.5.
0.
Still 0.
Oh.
0.9.
1.
Still 0.
Rounding down.
0.999.
Down to 0.
Still 0. Anything that starts with 0 and does decimals is going to be zeros. So let me graph a few of these. Where would 0.10 be?
Like,
Just over just a little bit. The 0.2?
Same thing.
A little bit more. 0.5?
A little bit over.
Halfway. 0.9?
Very close to the
Almost all the way. 0.999?
Pretty much
Pretty
all
Pretty much all the way. And if I sat here and did this all day, what would I eventually end up doing?
Maybe 1.
Fill that square.
I'm gonna make.
Would I want to ever land exactly on 1 though as part of this?
No.
No. So how do we in graphing show we don't want that?
Like, fill it in.
That we
Less
don't
than
want it.
sandwich.
An open dot.
Oh.
So we're going to go open dot at the end.
Shut up. You ain't gonna get it either, buddy.
What's going to happen in the ones?
They do the same thing.
They do the same thing. So when we get to the end of that square,
It's gonna be open.
it's an open dot,
Connecting them.
just fill it in.
Oh, okay.
When we get to the end of this line,
Same thing.
same thing. Just connect it, a square at a time. What you're going to get is steps. They're going to just keep going like this,
I don't like this.
literally forever. They're just going to go, 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 go. You don't have to do as many as I'm doing, but what you get is just a series of steps on a stairway to heaven. Who is that? That's an old band. Like Led Zeppelin or somebody? I don't know. It's like way classic rock from long ago. You're just going to get a bunch of steps. It's just, they're going to go forever and ever and ever. If I went to this and went +1,
Just move it 1.
all it would do is take all of these numbers and they'd all go up 1. So this whole graph
Stop 1.
just would lift the square. What if I switch X and Y?
Then it would be like sideways.
They go sideways. Instead of steps like this,
It would be.
we'd be going like this. It'd be, I call them Spider-Man steps. Like humans aren't climbing those. You need web to get up. But you get a bunch of like vertical wall kind of steps. Where we are on homework, we are 119. The first 6 are vertical line tests, yes, no's. Then the next 10 are the f of x, like plug them in, like the example I did with 5x minus 1. Just plug the numbers into the formula that they give you. 17 to 24 are the domain questions, like x is not allowed to equal this, or all real numbers, or whatever they may do. 25 to 30 we're going to graph, so I'd want to see a table of 5 and make V-shape always for the absolute value graphs, 25 to 30. And then the last 3 are going to be these steps things. 31, 2, 3, we're going to go some kind of steps. I'd again want to see a table of at least like 3, because all you need is the basic squats. Like, let me do one more quick one of these. Let me go x equals brackety guy, y plus 2. So would I pick for x or y? Y. 0, 1, 2. Put in 0, get out 2. 1 gets you 3. 2 gets you 4. So do those points. 2, 0, 3, 1, 4, 2. Are these going to step the same way I just stepped, or Spider-Man? Spider-Man. So we're going to fill in a vertical square with the dot, fill in a vertical square with the dot, fill in a vertical square with a dot. You could also call them lollipops, I guess. Lollipop tree. They're just gonna go. If it's y equals, fill in your steps across. If it's x equals, just keep stepping up. That's all I got.